Let's discuss the rules for differentiation. Let's start with the derivative of a constant. The notation for derivative is d over dx, constant is c, and the derivative of a constant is always 0. So the derivative of any constant, the derivative of 5 is 0. This makes sense because the y is equal to a constant number, like let's take 5 for example, is a horizontal line and the slope is always 0. Now let's go to derivative of, let's do the power rule for derivatives. And the power rule for derivatives is, so if you have power, the derivative of x to the nth power, the derivative will equal to n x to the n minus 1. So if you have y is equal to x to the fourth, the derivative y prime, it would be equal to 4x cubed. Now let's try the constant multiple rule. This basically states that if you have a constant multiple before any variables or anything else, the constant actually stays, if it's multiplied, it actually stays multiplied, and the derivative follows. So here I'll just show in notation. C would be the constant in this case, and u will be whatever variable that follows, is equal to c multiplied by the derivative of whatever u is. Alright, now sum and difference rules. So this is basically saying the derivative of a sum can be separated and solved out separately. So the derivative of u plus minus v is actually equal to the derivative of u plus the derivative of v. Now let's try the product rule. The product rule is the derivative of two multiplied products, so u and v in this case, and that equals u multiplied by the derivative of v, which is dv over dx in terms of notation, plus v multiplied by the derivative of u. And the last rule that we'll be covering today is the quotient rule. Quotient rule. And this is the derivative of u over v. This equals v times the derivative of u, this is a bit more complicated, minus u times the derivative of v, which is dv over dx, over whatever v is, n squared. So those are all the rules. Now let's try some examples. Let's try some examples. So the first example we'll be doing today is y is equal to x to the fourth minus 7x cubed plus 2x squared plus 15. So the answer to this, we'll have to separate out each thing because of the sum and difference rule here. Because of the sum and difference rule shown here, we can actually just treat each thing over here as separate variables. So if we were to do this out, we would take y prime would be equal to 4x cubed, because this is the power rule here. The 4 comes to the front, that's the n, and then this is n minus 1. So x to the power of n minus 1, and the 4 is here. Minus 21x squared. Say again, this is just the power rule again, plus 4x. again the power rule, and then constant we discussed is derivative constant is always 0. So 15 is plus 0, so you don't have to write that. So this is y prime. This is the derivative of that. This next example we'll be doing is y is equal to x cubed over 3 plus x squared over 2 plus x. Now we can use the constant multiple rule here, and we can see that the constant multiple in this problem is, if we rewrite it, it's 1/3 x cubed plus 1/2 x squared plus x. So you can see now y prime, since the constant multiple rule states that it's whatever the constant is multiplied by the derivative of whatever comes after. So it's 1/3 times 3x squared, which is the derivative of x cubed, plus 1/2 times 2x, which is the derivative of x squared, and then the derivative of x is just 1. And if we were to simplify this, we'll get y prime is equal to x squared plus x plus 1. Alright, our next example will be to do with the product rule. So let's do, this example can actually be solved out one of two ways, but we're going to solve it using the product rule. It's x plus 1 times x squared plus 1. So just to review what the product rule is, again, it's right here. And so one way to do it would be to FOIL it out and then do what we're doing above here. But now we can also use the product rule, and it'll make it a little bit shorter and a little bit easier. So if we use the product rule for this one, the product rule is the u. In this case, let's just write what u is here, and this is v. So we'll call this u and this is v. And the product rule is u times the derivative of v plus u times the derivative of v plus v times the derivative of u. So in this case, u is x plus 1. The derivative of v is x. The derivative of v is 2x, and we'll add it to v, x squared plus 1, times the derivative of u, which is just 1, because that's a constant and the derivative of x is 1. And then we get 2x squared plus 2x plus x squared plus 1, which is 3x squared plus 2x plus 1. And this would be y prime. Right there. And now we're going to do one final example. Just make some space here. And this will be to do with the quotient rule. So again, quickly to review the quotient rule, it is just the v times the derivative of u minus u times the derivative of v all over v squared. So for the quotient rule, the example we'll be doing is y is equal to x minus 1 times x squared minus plus x plus 1 over x cubed. Now we can FOIL out the tops to just make it simpler. We get x cubed plus x squared plus x minus x squared minus x minus 1 over x cubed. This and this cancel out, this and this cancel out, and we get y is equal to x cubed minus 1 over x cubed. So much easier to work with. And now we label this top part u and this bottom part v, so it's just u over v. And now it's just, so the y prime is equal to v times the derivative of u, which is, it's v, x cubed, so again we have to keep these variables straight, times the derivative of u, which is 3x squared, minus x cubed minus 1, which is u, times the derivative of v, which is 3x squared. And then that would be all over v squared, which is x to the 6th, because v is x cubed. So y prime, if we were to simplify this, will be 3x to the 5th minus 3x to the 5th plus 3x squared over x to the 6th, giving us the final answer of 3 over x to the fourth, because this and this cancel out, and when you simplify you get 3 over x to the fourth.